I did just want to quickly run through an example BeMS control and monitoring application to try and give some context to the things that we've talked about. So, there's me again. Hopefully you can see me. What I've done is I've created a simple supply air fan application. What this is a graphical representation of a very, very simple fresh air fan. On the left-hand side, we've got air coming in through an inlet damper. The inlet damper opens and closes when the system's running. We have an air filter. Then the air moves over a heating coil, which is controlled by a valve at the bottom. That passes across a thermostat, which we'll come to in a moment. We have a fan. And then just beyond the fan, you'll see a temperature sensor, and we have a little red arrow to indicate that we've got warmer air coming out the other side. So that's how this system is set up. And it's a very simple system, but how will we apply our BeMS to this system? So the first thing that we would need to do, we would need to start the fan and open the dampers. So we would typically connect those to a digital output on a controller. By putting them onto a digital output, we can switch the fan on and open the damper at the same time. And you would probably, on a system this simple, it would probably just be done on a simple time profile. We want to know whether the fan was running. So across the fan, we've actually got a differential pressure switch. It measures the pressure on one side of the fan and the pressure on the other side of the fan. When the fan is running, that causes the switch to activate because there is a difference in pressure from one side to the other. So now we've got our first real BeMS interaction. We can start the fan and we can see whether that fan is actually operating as well. If we know that we've started the fan and we don't have a fan operating, then we could raise an alarm. And typically what you do, you'd introduce a grace period for this. So you give the fan a chance to start. If we've started the fan and after 15 seconds, we don't have any airflow, then we can raise a plant alarm. So we would use the BeMS to do that. In terms of temperature control, we have a supply air temperature sensor, and we need to maintain a constant supply air on this system. So what we would do, we would use that signal from the supply air temperature sensor, and we would compare it to a set point that we've given it as a digital data point. And then we would manipulate the analog output to open and close the valve to the heating coil. In a very, very simple system, you could actually do this digitally. You could just open the valve and close the valve, but we get much better control if we open the valve proportionally to the demand that we've got from the temperature sensor. We can also use our system to monitor the filter status. We have a second differential pressure switch connected across the filter. And what that does, that looks at the pressure one side and the other side. As the filter gets more and more dirty, then the differential pressure increases. And when it reaches the dirty threshold, the switch clicks in. And again, we will probably get a plant alarm, or we might just have some kind of other information feeding through our system. But we can monitor that into our BeMS. The last part of this is our is our freeze protection. Now, there's many ways that you can provide central frost protection on a BeMS, but local frost protection is typically provided by frost protection thermostats. And what happens is that if it gets very cold, the frost protection thermostat clicks and it shuts the unit down. And that's usually a hardwired interlock that we see on that. But you want to know that that's happened. So you would take the status of that freeze protection thermostat and feed that into the BeMS so that someone would actually know about it. Energy saving using the BEMS, how does this relate to energy savings? In all honesty, I had to rack my brains about this one because on a system this small, it's quite difficult to come up with, oh, how do we use this to save energy? But just by having proportional control on the heating coil, you are going to be using less energy than if you're switching on off. You would probably, on a system like this, actually have some kind of speed reduction on the fan as well. If you were looking to optimize this, I would suggest probably the best energy efficiency you could get out of this would be scheduling the supply air temperature set point based on the outside air temperature, which if we've got networked controllers, although it's not shown on this diagram, would be very easy to do. So on the warmer days, we can save heat energy by not heating our air so much. So just as a summary there, using the example, we've learned how real-world values are used to provide control and monitoring. This is just a very small example. Obviously, if you have a very large building, then you're going to have much more complex plant and much more scope for saving energy as well. And this is where the BEMS comes into it. For those of you who are working in admin roles, etc., you've probably seen dozens of controllers going into panels going out to site. This is how they fit in to small systems like this, to very large systems, complex systems with recirc and heat recovery, etc. But it's all based on the same principle. You have analog and digital inputs, analog and digital outputs, and you have a control application, which your excellent and brilliant value engineers are creating in the middle and then going out to site and commissioning. So that is everything for this course. If you want to do any further learning, then there's a couple of places that you can go. If you go to bcia.co.uk/training, they have a full set of courses there which are available. Also, if you are down in the south of England, you could visit the Sonte Academy website. They offer the full range of BCIA training courses. Would seriously advise you don't go to Sonte if you didn't enjoy my training, because I do a lot of the training there. But in addition to the BCIA training, they have a range of CPD courses, continuing professional development courses through CIBSE as well, which they can deliver in-house. Quite possibly, if this has gone well, maybe we'll be able to deliver those online as well. This is the first time I've done a webinar, an online course. It's really weird. I'm used to being able to see people. I do welcome any feedback. If you have any comments, positive or negative, I would appreciate if you could send those through to me. I hope you enjoyed it. I hope everyone is staying safe and well. And yeah, maybe I'll see you on a future course. Thanks very much for coming along. Bye now.